Alrighty, in this video what we're going to do is we're going to provide a system that gives more visual feedback to our player when certain things happen. For example, if I go ahead and start the game right now, you'll notice I really don't get a whole lot of visual feedback when I hit the stars. I mean, sure, they disappear and play that cool little particle effect, but what's actually happening is kind of lost on the player unless they happen to look at the top left and see that they received more points. In addition, when I take damage, we can visually see how much damage was taken, but we can't see that number numerically. Finally, when we hit a checkpoint, which I just got pushed off by a moving platform into the sticks, and then I got stuck in that. There we go. When we hit a checkpoint, there's no visual indication other than the top left-hand side of the game that tells us that we have hit a checkpoint. So I want to solve this with a very straightforward, commonly used technique of showing little bits of floating text when certain things happen. I want floating text to either appear at a certain point in the world, or I want floating text to appear in the center of the screen. That way we can give the player more visual feedback as to what's happening in the game. Alright, so like I said, I'm going to generalize it into the concept of a floating text. Now, a floating text is going to require us to put together a couple different things in order to make this kind of extendable and usable in multiple scenarios. So I'm going to start off by creating a new class. So I'm going to go into my code folder in my assembly C# VS, create a new class, and I'm going to call it floating text. Now, floating text is going to be a mono behavior. I'm going to remove the namespace from the file, and I'm going to have it implement or inherit from mono behavior, which of course will bring in a using Unity engine up at the top. As far as the innards of the floating text go, what I want to do is I want to go ahead and write the stub out for our floating text mono behavior, and then write all the other types that we're going to be needing to work with in order to use our floating text system. Because as you'll see, we're going to need an interface and a couple implementations of that interface in order to use our floating text. So the first thing I'm going to do is I'm going to say private static read-only GUI skin equals resources dot load GUI skin floating text skin. Or sorry, not floating text skin. What am I doing? I want the game skin that we're using. Remember, we're doing resources.load, so I need to pass in a path to a resource. So the resource that I want to look at is going to be inside of Unity, inside of our resources folder, and you see it's called a game skin. That's because I want to be able to style all of our bits of floating text by just adding a new custom style to our GUI skin, our game skin. So I'm going to go ahead and I'm going to copy that text, jump back into Visual Studio, and then I'm going to type in game skin. So that's going to load our GUI skin in for our floating text. Next up, I'm going to say public static floating text show. It's going to have a string text, string style, and then an I floating text positioner. Now, I floating text positioner is a interface that has not been created yet. All right, so now we have that. Let's go ahead and create our innards of our floating text first, which will have a private GUI content underscore content and a private I floating text positioner. Then we're going to have two public properties, public string text, which public string text is going to be a property, but it's simply going to return content.text, and the setter is going to say content.text equals value. Then I want a public GUI style, which is a getter and has a public setter. Next up, we're going to need a public void on GUI method. Okay, so this is basically a nice little stub out of our floating text behavior, but we're missing a couple key components. first of all, we need our iFloatingTextPositioner interface, and we're also going to need a couple of classes that can be used to fulfill this argument. So why are we abstracting the concept of floating text positions? Well, the reason is for right now, I can foresee two different methods of positioning our floating text. One that positions it over the entire screen, centered in the middle of the screen, and another one which will result in a particular point in the world causing that floating text to happen. So that's why I want to abstract it into an iFloatingTextPositioner as opposed to having that built in or baked into our floating text manager. Now, the rest of these two methods, the show and the onGUI methods, are pretty simple enough, so I kind of want to just go ahead and write them before we write our iFloatingTextPositioner interface, and it'll give us some context as to what exactly the floating text positioner needs to do. So what I'm going to do is implement the show method. The show method is going to instantiate a new game object. I'm just going to say go game object, and I'm going to call it floating text. And then I'm going to say var floating text equals go add component floating text. So floating text is a mono behavior. We're instantiating a game object, we're naming it floating text, and then we're instantiating the floating text component on that game object. Then we're going to say floating text dot style equals skin dot get style style. So this will allow us to retrieve the style from our GUI style or our GUI skin. So that means different bits of floating text can have different colors and different fonts and different positioning. Then I'm going to say floating text dot underscore positioner equals positioner, and then floating text dot underscore content equals new GUI content passing in the text that we want to display. Then I'm going to say return floating text. Now in this particular setup that we're going to be doing with floating text, we're not going to be using the return value for anything, but I kind of wanted to return out back a floating text in case an object that takes advantage of floating text might want to update the text or the style of the text after it's been instantiated. Okay, so now we're going to write our onGUI method, and our onGUI method is going to include a invocation of a method on our positioner. Basically, we're going to be like, hey, positioner, where do we want to position our text on this frame? The positioner will do one of two things. It'll either A, return a position indicating where we want the text to be, or B, it will return false indicating that we no longer want this floating text to be active and it's now safe to destroy the game object. For example, we might want to say if we have floating text that appears in the center of the screen, when it gets up to the top of the screen, we want to automatically destroy that floating text. So what I'm going to do is I'm going to say var position equals new vector2. Then I'm going to say if not positioner.getPosition ref position underscore content, and then passing in style.calc size of content, then destroy game object and return. Otherwise, we're going to want to go ahead and say var content size equals style. Well, we can actually reuse that, can't we? We can say, we can grab this, we can refactor it out, and we can say content size. So what I've done here is instead of passing in style.calcSize into our getPosition method of our positioner, I am calculating it here once, and then I'm going to reuse it again. So now what I'm going to do is I'm going to say GUI.label, passing in a new rect of position.x, position.y, content size.x, content size.y. For our content itself, we'll pass in underscore content, and for our GUI style, we'll pass in style. Okay, so again, we haven't yet implemented our iFloatingTextPositioner interface yet, but what we're looking at is a usage of it. What we're going to do is we're going to first calculate the size of the content, in this case, the text that was passed into the show method of floating text. Then we want to tell the positioner to get the position that the text should be displayed at. If positioner returns false, however, we will destroy the game object and exit out of our GUI. If it returns true, that means the position is set to where the positioner wanted our content to be positioned at, which means we can use it in a GUI.label invocation to position it somewhere on the screen. Okay, so we now have enough information to implement our iFloating text positioner. So let's go ahead and do that. I'm going to come up here to code, and I'm going to create a new interface called iFloating text positioner. And then I'm going to remove the namespace from it. And I now have an interface called iFloating text positioner. I will, however, need to have a using Unity engine at the top so that I can reference some of the types that I'm going to be needing for its single method. This interface will have one method on it. The method will be bool getPosition with a ref of vector2 position, a GUI content of content, and a vector2 of size. So any class that implements this interface can position a piece of text as it floats across the screen based on whatever criteria you want. For example, it could be in a point, the floating text could follow something, the floating text could appear in the center of the screen, then scroll up. We basically created a very nice sort of abstract way to deal with floating text. And you see that since we created that interface, we now have this code all compiling correctly. Now that we've done that, let's go ahead and show you guys an example of a floating text positioner. Remember, it's an interface. It doesn't contain an implementation. It just contains a contract. In order to actually use the show method of floating text, we have to make a class that implements iFloating text positioner. So let's go ahead and write one for FromWorldPoint text positioner. So I'm going to go up in code. I'm going to write a new class, and I'm going to say FromWorldPoint text positioner. Then I'm going to make it not be in a namespace, and then I'm going to make it implement iFloating text positioner, and then I'm going to implement that one method. So what we have here is a class FromWorldPoint text positioner that implements iFloating text positioner, that implements the single method from this contract, and then also our using Unity engine at the top. So the FromWorldPoint positioner, I wanted to have a constructor that takes in some parameters about the specific kind of positioning that we're going to do. Now the parameters that we want is a camera. We need to know what camera is considered to be the main camera. Then we need a world position. Then we need a time to live, and then we need a speed. So, just looking at this constructor, we see that the FromWorldPoint text positioner takes in a world position somewhere in the game level. Then it takes in the amount of seconds we want the text to appear, and then it takes a speed, which is how fast we want the text to go up. All right, let's go ahead and take all these constructor parameters and turn them into private variables, private fields, I mean. So what I've just done is I've created a private read-only camera, private read-only vector3 world position. I'm going to have a private float time to live, which will not be read-only. That's because we will be modifying our time to live on every frame. And then we have a private read-only speed. All these local fields are initialized by the corresponding parameters to the constructor, as you can see here on lines 12 through 15. So now we have enough information to actually write some code that will result in a piece of floating text appearing on the screen. I have to point out though, we are using two different coordinate systems. The coordinate system that we need to return is the GUI coordinate system. We know this because by looking at floating text, we're using our GUI label method, and our GUI label method expects positions to be in GUI coordinates, not in world coordinates, and not in viewport coordinates. However, our FromWorldPoint text positioner accepts a world position, meaning an X, Y, and Z position that corresponds to somewhere in our level. So the reason why we have a camera being added into this class is so that we can calculate where on the screen a particular object should be relative to its world coordinates. All right, let's go ahead and write our getPosition method. The first thing we have to do is say if time to live minus equals time.delta time is smaller or equal to 0. Return false. What does this mean? Well, this means that every frame will subtract time.delta time from time to live, and if that value ever becomes smaller or equal to 0, we return false. That indicates to our floating text on GUI method that it is time to destroy the floating text and have it no longer appear. Then we need to calculate the screen position. So I'm going to say var screen position equals camera.world2screen.point world position. Then I'm going to say position.x equals screen position.x minus size.x divided by 2. What does this do? Well, remember, our size parameter that's passed into getPosition, if we look back at floating text, that size parameter is the size of the content in pixels. For example, the size of that text in pixels. So by doing this, we will center that text on the world position. Then we want to say position y equals screen.height minus screen position.y minus y offset. Then we want to say y offset plus equals time.delta time times underscore speed. And we finally want to finish this method by returning true. Returning true indicates to our floating text that we still want the text to be around. However, we do have a slight problem. Our y offset field has not been created. So let's just jump into our top of our file and say private float y offset to correct that error, and our code will now compile. So our y offset is added by the amount of seconds that have passed since last frame, scaled up by the speed that we want the text to go in. Alrighty, so let's go ahead and show a usage of this. Let's jump into our, what did we call that? Point star. And let's go ahead and show text that indicates how many points you received as a floating text manager invocation. So after we've added our points, I'm going to say floating text dot show, passing in string.format placeholder, plus placeholder exclamation point. For the placeholder, we're going to add in points to add, because that's what we want the text to be. Our style name will be point star text. That's a nice name. And then for our text positioner, we want to instantiate a from world point text positioner, passing in camera.main, transform.position, time to live 1.5 seconds, and speed 50. And then we want to terminate this line with a semicolon. So it is a bit of a long line, but it does a lot of cool stuff. First of all, it creates the text that I want to have appear. For example, +10 exclamation point or +20 exclamation point, however many points that we added to the player by hitting this particular star. Next up, we pass in a style name, point star text. Now this style doesn't exist yet in our GUI skin, but we'll be creating it momentarily. This will allow us to control the presentation of how this text appears. The last thing we do is we specify the text positioner, indicating that we want it to appear from a world point and go up for 1.5 seconds, and we want it to go up by 50 pixels a second. All right, let's exit out of full screen and jump into Unity. What I'm going to do is I'm going to go ahead and first of all, I'm going to create this GUI style, point star text, by going into Resources on our project window and clicking on Game Skin. Inside of Game Skin, I'll scroll down to my custom styles. I'll add a new custom style, 4, and I'll hit enter. I'll open up the one that was just created. I'll change its name to point star text, and then I'll change some of these parameters. The normal color I want to be yellow. Just a really bright, obnoxious yellow. Hover, active I don't care about. Margin I want to be 000 Padding, I want to be 0, 0, 0. Font size, let's do 12. And then for alignment, I'll do middle center. And I'll turn off rich text because we don't need that. And yeah, that's really all we'll really need for our text style. So let's hit play. See what happens when we jump over one of these stars. As you see, it's kind of difficult to see. Maybe we should up the font size to maybe 14. With that platform of death, this game is actually kind of difficult. Okay, but as you can see, we indeed now have floating text that floats up and automatically destroys itself and says plus 10, plus 10, plus 10 when I get 10 points. Looking good?
It's really difficult for me to see with this frame rate. It's disappearing on me. A couple of them I caught look pretty good. Oh, there we go. There, I saw that one.
Alrighty. Yeah, I think that's acceptable. Of course, people can go in and modify it to do whatever they want. I mean, after all, it's code. But let's go ahead and add in some more floating text for when the player gets damaged. So when the player gets damaged, I want to show exactly how much damage the player was given in the form of floating text. So let's go ahead and jump back into Visual Studio, and let's locate our player script, which is over here on the right-hand side, near the bottom. I'm going to scroll all the way down to my take damage method, and I'm going to go ahead and at the top of my take damage method, I'm going to say floating text dot show string dot format minus placeholder, passing in the damage as the parameter for that placeholder. For the text name, I'll say player take damage text. And for the floating text positioner, I'll do from world point text positioner, passing in camera dot main transform dot position, time to live, how about 2 seconds, and then speed, let's do 60. Okay, so again, the line that I added was floating text.show, passing in minus the amount of damage given, passing in the player take damage text as the style name, and using a world point text positioner, passing in the camera, the player's position, a life of 2 seconds, and a speed of 60 pixels a second. So let's close out of full screen, jump back into Unity, and let's go into our game skin and actually create that style. So up here, I'm going to say size is going to equal 5. And then on the new style that was created, I'm going to give it the name of player take damage text. The color, I want to be a bright red. So that's what I want there. The size 14 is good. For the font style, let's change it to bold and see if that looks good. Okay, so I just modified that style. Now whenever I take damage, I should, indeed I do. We can maybe make it a little bit bigger, maybe 17 points. And indeed, we do see that bold text indicating that we took 25 bits of damage. All right, so we have one more thing that I want to do here, and that is whenever I hit a checkpoint, I want floating text to appear in the middle of the screen telling me that I hit a checkpoint and how many bonus points that I received based off the amount of time that it took me to reach that checkpoint. However, I don't want to use the text positioner that we just created. Instead, I want to create a centered floating text that's centered on the screen. Fortunately, it'll be a lot easier to implement than our previous one. Coming back into Visual Studio, I'm going to click on our code folder. I'm now going to add a new class, and it's going to be called Centered Text Positioner. I'm going to remove the namespace definition. and it's going to implement floating text positioner, which, if we go ahead and have it implement that method, results in the get position method being added, as well as the using Unity engine namespace up at the top. Now he's going to need a constructor, and the constructor is then taken simply a speed. And the speed is going to be brought in right here and aliased out into a private field. In addition to knowing the speed, I need to have a private float text position that'll keep track of where exactly the text is on the screen. Okay, so now what I want to do, well, actually, let's just talk about this code for a second. So I have a private read-only float speed, and I have a private float text position. I have one constructor that takes in a float speed, and all it does is it assigns our private field speed to the parameter that was passed in by the caller. Now we have to write our get position method. What I'm going to do is I'm going to say underscore text position plus equals time.delta time times underscore speed. If text position is greater than 1, return false. That's because text position is going to be a number between 0 and 1 indicating how far along the text is. Then I'm going to say position equals new vector2 screen.width divided by 2f minus size.x divided by 2f. This will center the text on the screen. For the y parameter, I want to pass in mathf.linear interpolation screen.height divided by 2f. And then I want to say, in addition to screen.height divided by 2f, I want to say plus size.y so that it scrolls all the way past the screen and doesn't just stop when it hits the top of the screen. And then I want to pass in a 2 parameter. So that's the from parameter. The 2 parameter is 0. And then the time is text position. And then finally, I want to return true, indicating that the text should still be present. Alrighty. So now that we've done our centered text positioner, we can now jump into our level manager and actually add an invocation to our floating text code that will make this appear. Actually, on second thought, I think it would probably be more appropriate to add this to our checkpoint class itself, as opposed to our level manager. So let's go into our checkpoint class, and let's work on some of this code. Right down here, for player hit checkpoint, you'll notice it takes in a bonus. Now, this is a private coroutine that hasn't been invoked yet. Remember, the player hit checkpoint is what's going to be invoked by our level manager. So what I want to do is I want to come here and say start coroutine player hit checkpoint passing in a bonus of level manager dot instance dot bonus, which is current time bonus. Now, why am I creating a coroutine and why am I passing in a parameter of the current time bonus? The reason is a coroutine is going to be executed over the course of multiple frames. But if we look at the code that happens immediately after we invoke the player hit checkpoint, you'll notice that it resets our bonus. That means that by the time our coroutine will have been executed, our level manager's bonus would already have been reset. And then the bonus that we might be able to display inside of our code right here with our floating text would be out of date. So we don't want that. Okay, so let's go ahead and write our iterator or our coroutine. Our coroutine is simply going to say floating text dot show. We're going to say something like checkpoint exclamation point, passing in a style of checkpoint text, and then passing in a floating text positioner of centered text positioner, which only requires a parameter of speed. And the speed parameter we're going to pass in is 0.5. 0.5 is going to result in it taking about 2 seconds for the text to appear and disappear. Then I want to say yield return new wait 4 seconds, 0.5f. Then I want to say floating text.show string.format plus placeholder time bonus, showing the player how many points they received for their time bonus. Then for the style, I'm going to pass in checkpoint text again using the same value, the same style. Of course, we could use a different style if we wanted to, but in this case we're using the same style. And then I'm going to pass in a new instantiation of centered text positioner, passing in half or 0.5 for its speed value. All right, now if we go into Unity and we hit play, we'll see that blah, blah, blah. When we hit a checkpoint, we get an error. The error says object reference not set to an instance of an object. The reason that's happening is that I forgot to actually create the checkpoint text style on our GUI skin. So that's a nice little reminder for us when we forget to create the style that our code depends on. In this case, we got a null reference exception. So coming over here into our resources game skin, let's scroll all the way down to the bottom to our custom styles. Type in 6 and hit enter. Come here to this custom style, click on this and paste and hit enter. So now we have our checkpoint text. I want to go ahead and change the color to white. Then I want to go ahead and do its font size at 25. Keep it at a normal font style. I think that's all I really want to do with it. Alrighty, so let's go ahead and hit play. And now see what happens. Indeed, we get a checkpoint. And we get a checkpoint. However, we're now getting a format exception. It looks like our time bonus, we have a slight problem with our time bonus, and that's because I specified the format string, but I didn't actually pass in the parameter that placeholder depends on. So now I'm going to type in bonus so that that bonus gets inserted right there where that placeholder is. All right, so jumping back into Unity, we should finally see checkpoint, 30 time bonus. Checkpoint, 33 time bonus. And I think we only had 2 checkpoints. And now if we die, we indeed get set there, and our points do get reset. I don't know if we ever checked that. Yeah, points do indeed get reset. All right, so I think the floating text looks pretty good, actually. It really does add a lot of... it's a very subtle effect that adds a lot of polish to a game like this. And you can definitely do a lot more interesting things with the floating text, like maybe change the opacity of the text and do all that fun stuff. But for right now, for our purposes, I feel that that is sufficient for what we want to accomplish. All right, I think that pretty much wraps up floating text. So we'll see you guys in the next video.